Well, Rúben, hello to the channel.
Hello, how are you?
Welcome to the channel, I should say.
Thank you very much. I'm happy to be here and to help you, hopefully to increase your channel. Who knows?
Yeah, so let's begin our conversation about RAN.
Okay.
And my first question for you is, what is RAN?
Okay.
I'm asking for a dummy friend who's never heard of this. Like, could you explain this abbreviation?
Yes. So basically, RAN is the acronym for Radio Access Network. And basically, if we want to describe a mobile system, I think I can draw it.
Yeah,
we can divide it into, let's say, three main parts. So this is the core network. Then we have the RAN. And then we have UE. This is basically
User interface, right?
yeah, terminals.
So basically mobile phones.
Yeah, so basically the RAN is this middle sector in an end-to-end, in the end-to-end network, where basically that communication between the user and the core network, which is where the information from that the user requested is transmitted to him, to them.
Where does base station sit in this?
Yeah, so basically, just to understand like the RAN position, and we can still add another final box, which are services.
Okay.
Okay, and this is basically internet.
The kind of backbone stuff.
Yeah, so this is where all the information is stored, like servers and stuff like that, and then the core network takes these services, transmitted to the RAN, and then to the end user. Okay, so RAN is this intermediate section where we have the base stations.
Okay, so there they are.
Yeah. So this is where we have the base stations, and here is where we have the mobiles.
Okay.
That's fine. So they communicate with the base station through the RAN. That's fine. Okay, so this is basically what the RAN does. Okay, so it defines the interface between the end user and the network, and then it transmits all the information to the core network to get the services that the user requests.
How does it communicate with the core network? Is it
okay? So there's basically we have interfaces. So here is what we call air interface.
Yeah.
Okay. So basically, then the RAN. Okay, and the communication with the core network is mostly done with wired signal, okay? Whether it's fiber, mostly fiber at the moment because it's the fastest way of doing it. We can have some microwave technology as well if we don't have enough fiber to do the connection between the RAN and the core network. If the nodes are too distant from each other, we can use microwaves, but usually it's fiber.
Okay, but obviously microwave communication will be quite direct, and like you would have terrible path loss if you do that.
It's good if you can have line of sight to do that.
Yeah, it has to have line of sight. Okay.
Yeah, so this is like just a general position of RAN in the entire network.
So what are the main types of RAN in existing architecture and like?
Okay.
Yeah.
So basically the RAN is very similar there's not many different types of RAN inside the same cellular technology. Okay, so we have different architectures for 2G, 3G, 4G, 5G, 6G, but inside each technology the RAN doesn't vary too much. Okay, maybe sometimes when we are doing a transition from one technology to the other, there are some concepts that start to appear, and it might change some of the mechanisms in the RAN. But in general, it's very similar. So, for example, one interesting fact about RAN is how it evolved during the different mobile technologies.
Yeah.
And while in 2G, we usually have these base stations like this, or like that, and basically these base stations are then aggregated to a controller. Okay. In 2G and 3G, we used to have this kind of architecture where the base stations were organized by area, and each area was controlled by a central controller.
I see,
okay?
yeah.
Okay, when we moved to 4G, we still have some controlling systems in the RAN, but it's different because we moved to a more distributed architecture where the base stations can actually do some processing. Okay? So they are not just simple nodes that work like a hub, just forwarding signal.
So they have some sort of intelligence.
Yeah, they have some sort of intelligence. So we don't have this central controller. We have other mechanisms to do some management of users inside them, to keep track of users inside the network, what kind of services do they have, what kind of services they paid for, so they keep track of this kind of information, but there's a lot of intelligence being done by the base stations. When we move to 5G, we are again going a bit toward decentralization. Okay. Yeah, because there's different mechanisms that are going to be applied, and a lot of new services that require high processing and that require a view of the entire network. So it's better if we have more processing in a central unit that understands the entire network. Okay, so this is a bit of the difference that we have in the different technologies.
Yeah, I was about to ask you, the next question is about 5G and how is it evolving from 4G architecture, and what is gonna be the main difference?
Yeah, okay. Yeah, so as I said, so there are a lot of differences between 4G and 5G. And basically 5G is, it will change a lot the way that the network used to be designed, because we are moving from a physical infrastructure to much more digitalized infrastructure, okay? So 5G is all about digitalization of all the interfaces, all the controllers. So I can just exemplify something.
So does it mean that the controller block is going to be virtual now?
Yes, at some point. So in 5G, we have two main technologies in the RAN. Let me put the RAN. So basically for 5G, there are two main technologies, which is SDN for software-defined network, and NFV, which is network function virtualization.
Okay, yeah.
So the idea is this will work much closer. So actually the evolution of cellular networks has been in this way. So the architecture of the network is much more closer to computer system, okay, where we have routers and this kind of signal transmission, okay, information transmission. So we have several nodes, and for example, we have a centralized control, which is software defined. So this software defined network, we can see it like a central controller, okay, where we have information of all nodes in the network, like in a table, and all the paths between the different nodes, okay? So in 5G, we will have something like this. So we have one node here, then one bigger node, okay? So we have different aggregation nodes. So this is basically as a IP system, okay?
Yeah.
And the same for this. Yeah, and then we connect to more base stations.
So when you draw each circle, what does it represent?
Yeah, this is like that. It's what we call an aggregation node. Okay, this is how basically the signal transmission is done in the RAN if we have a SDN and FV. So while before we used to have the controller that I said that was responsible for a certain area, we had multiple controllers. So now we basically have one controller, and then we do like a web of different nodes to transmit the signal. Okay. And by doing this, we have much more flexibility, because usually we can protect the network against failures. Okay, we have if one node fails, usually we have a different route to get to the same node, to the same base station. Yeah, so this follows basically a computer-based signal transmission with routers and and then this is the SDN idea, okay, and then we have NFV, which is about virtualization. And to go here, I need to draw some new stuff again.
Yeah, so each node is responsible for some certain amount of users,
Yeah.
but then they have different no, basically what they following those greedy paths or something like that, isn't it?
Yes, yes.
Yeah. So NFV, yeah.
Yeah, let's go to NFV. So basically, this is important to know, which is in a 4G network, okay, we have the base station. And the base station is typically composed of two main structures, the RRU, okay, and the BBU.
Okay.
Okay.
And what do those mean?
RRU is remote radio unit, okay,
Remote,
and this is
okay.
baseband unit.
Okay.
So this basically handles the RF, the radio frequency part of the network. So it receives the signal, transmits the signal,
So
and
antenna,
yeah, it's
Okay.
a module that is very close to the antenna, and it's more it handles the signal, the reception and receiving of the signal. The BBU is where the major processing of signal is.
Okay, so this is your controller.
Yeah, it's basically the controller.
Okay.
Okay, and the network has been evolved a lot. So BBU, we can have different structures. Okay, so initially we used to have a BBU and an RRU in each base station. Okay.
Yeah.
So that's why I said that the base stations in LTE, they do some processing themselves because they have these processing units in each base station. By the way, base station in LTE is a E node B.
Okay.
That's how we call it. Okay, E node B.
Mhm.
Yeah. Then we started to evolve to a pool of BBUs. Okay.
Mm-hmm.
So instead of having just one BBU in each base station, we can actually have a more centralized system with different BBUs. Okay.
Okay, so they all
And then just
kinda located
assign.
in the same box.
So this is a centralized unit, and then we can assign this BBU.
So they talk via
Yeah.
some RG45, basically, like some Ethernet cable, isn't it?
Sorry, what?
How is controller talking to RPU? Is it just like a Ethernet cable, isn't it?
Yeah. Yes. So they are connected by fiber typically.
Oh, fiber.
To the base station, and we can use it. So this is a bit more interesting because first of all you have a more modular system. So if you need to assign more processing capacity to one base station, you can
Yeah.
do it. If you need to manage the hardware itself, it's much easier to do it when it is centralized. To make any changes, you can just go to here and do the modification that you need. Yeah, so this is one of the architectures that we've been
So
doing.
that's been introduced when? In 4G or
This is
5G?
still 4G.
This
but
is
it's
still 4G.
Yeah, this is still 4G, but you can call it 4G advanced,
4G
LTE
plus.
advanced, okay?
Okay.
Yeah, and this is a pool of BBUs or BBU stack.
Yeah, okay.
Yeah, and okay, in addition, so then we have a protocol. So this is typically the connection is being done with fiber, okay?
Yeah.
But then we have a protocol here, which is the C3 protocol,
Okay.
which is the protocol that basically establishes the connection between BBUs and RRUs.
Okay.
And this is a proprietary protocol, okay? So it depends on the vendor.
Yeah. Okay. So it's different
Yeah.
for every
Yeah, so
service
in
provider.
cellular networks we have three main vendors, which are Ericsson, Nokia and Huawei. Okay.
Okay.
So basically when an operator, a mobile operator like Vodafone, Telefónica, whatever, when one of these operators want a base station system and the hardware, usually they talk with one of the vendors and they get the full package, okay, for their system. So this is all proprietary software or interfaces.
Right.
So this is one of the things that 5G will change the most, okay? Okay, first of all, 5G will do one thing, which is making the BBU we'll separate the BBU into two different sections. Okay, so I'll take this out.
Okay.
So the BBU is this. This pool of BBUs is the most common implementation nowadays. But then we are also progressing to virtualization, as I said.
Okay.
And centralization. So this is one initial step for centralization, and then we can have these physical BBUs per each vendor in each network, or we can start to have them in the cloud. Okay.
Okay.
Where what we call a CRAN, we can call it Cloud RAN. Okay.
Cloud RAN. Okay.
Yeah. So in the CRAN, we basically have this into the cloud. Okay. Instead of being physically.
And that is still 4G.
This is This you can call it the transition to 5G.
Into 5G.
Yeah.
Okay.
So this is in the cloud, and then we still have virtualized RAN, which I will explain later. But the first thing that we do with 5G now, one of the most important changes, is that we will divide this BBU into. You will not see it. Into CU and DU.
Okay.
Central unit, distributed unit. Okay, so we pull it, we will make it even more modular. Okay,
Yeah.
and it's also important to say that in a base station, we have in LTE we have different stacks. Okay, inside the base station. So we have physical layer. Okay, we have MAC layer.
Yeah.
We have RLC. We have PDCP. And then we have RRC. Probably we have some more layers, but these are the main ones. Okay?
Okay.
And basically, what we see is the RRU is basically responsible for the physical layer, then the BBU is responsible for the remaining layers.
Is it at all similar to IP stack or not so much?
Exactly as IP stack.
It's
That's why I was saying that from 4G mainly to 5G, we are moving to that IP architecture.
Okay.
Yeah. So I was saying that basically these are the stack layers that we have in the base stations. Okay, and then RRU is responsible for physical layer mostly, and then BBU is responsible for the other layers.
Yes.
When we basically separate BBU and the BBU in CU and DU, we are basically assigning different layers to these two components. Okay, so
Yeah.
again, this makes the network more flexible because we can assign more easily different amount of processing capacity depending on the requirements of the base station. Okay, so this is one of the main changes in the 5G architecture.
Mm-hmm.
Okay, so then when we enter into virtualization, we are basically running away from this hardware. So usually these BBUs, the CU, the DU, the RRU, they are physical hardwares that are just designed for that purpose. Okay?
Okay.
You can put it like, let's say, a PS5 or an Xbox. So
Yeah.
you only can play PS5 compatible games. Okay, this is like
So
a
they made like by
proprietary.
Nokia, and you can't
Yeah.
use Huawei.
Exactly.
Box
exactly.
instead.
And
it won't talk to Huawei box
Yeah.
even.
Yeah, and it's not only that, it's the fact that, okay, you have a BBU, it's a piece of hardware that only works for baseband unit processing, okay?
Right.
You can't do anything more. So you are moving now with 5G to a virtualized system, where basically, instead of having these
All those hardware boxes.
hardware specific BBUs and CUs and DUs, we have basically data servers or
Yeah, that's pretty smart. Yeah.
just virtual machines where then we can deploy a BBU or per a CU.
Yeah. Okay.
We can deploy like a CU or many DUs, for example, in each, and we can change. We can assign. We can just deploy as many units as we need. Okay, and we can also deploy other kind of
So
technologies, for example, for mobile edge computing.
yeah, so it gives you a certain degree of customization, I suppose.
Yes, exactly.
But doesn't it make it less secure though?
Security is a tough question. Yeah, I think 5G is yeah, and not only that, because we are moving, and this is a bit. When you start to talk about this kind of concept, we are also moving towards the ORAN and an open air interface, all of these concepts that are appearing with 5G. And of course, security is one of the main concerns about all these technologies, because we are making the network much more open than before, but much more free to use. So yeah, security is some of the big topics for 5G, but I think there's been a lot of research work about it. And yeah, but it's not at all my area of expertise. But yeah, it's for sure an important step.
You mentioned ORAN. I mean, I think that's been one of the big buzzwords with 5G and potentially 6G as well. But why is ORAN? Why is so exciting about it?
Yeah. So RAN is very interesting because it's like, if it goes ahead, I think it is one of the major changes that we have ever had in radio access network. And on the other hand, it is basically a natural evolution of what we are seeing here. Because as you are seeing, we are moving away from the traditional hardware that does a specific function, and we are moving it to much more distributed. We are centralizing some of the processing, but the way the central unit works is a much more modular. We have a kind of distributed system there, and we are moving to virtualization, to cloud computation, all these concepts. Okay, so naturally we are moving to Open RAN. Why? Because Open RAN is basically about opening the interfaces, okay, between all the systems in a radio access network. Okay, so for example, one of the main changes in ORAN is this protocol here. Okay, the CPU. Yeah, because this is proprietary protocol. So it means that when you want, let's imagine that you have an antenna system. Usually, it is completely attached to the baseband unit and to all the processing units of that vendor.
Yes.
Okay, if we start to open these interfaces, so make them. We have basically a specific communication that needs to be, or specific communication capabilities that need to be followed by everyone. So it means that almost any player in the market can develop hardware for...
Yeah, you said there are only 3 players at the moment.
At the moment but we are starting to see a lot of new players like Rakuten, for example, or...
Okay.
What's the name? Mavenir. Okay. And even other players from different markets are starting to enter in the telecommunication business, like Microsoft because of the Azure system, or Amazon because of the AWS. Okay.
Can it ever become something completely open source and available to everyone?
This ORAN system, it opens the interfaces, so it allows that many more players enter into the telecommunication markets, and mainly the operators are not locked to the 3 traditional main vendors, so we can open this. And now I can enter a bit more, just very briefly, because it's inside the same concept, the virtualization. Okay. Because
vRAN is another big concept, isn't it?
But it's very similar to all of this, because we moved, as I said, to a pool of BBUs, which is a cRAN, so a cloud RAN. That's what we call the cloud RAN, because we have all these processes centralized, and they can be deployed in the cloud.
So what is the difference between cRAN and vRAN?
Yeah, the vRAN is basically, it goes exactly towards the ORAN concept. So it's an intermediate level where basically the vRAN is the concept where we start to decouple the hardware.
So it becomes more and more software and less hardware, basically.
Yeah, so basically with NFV, while with the pool of BBUs we still have proprietary hardware or functions, with the virtualization we start to decouple these functions in terms of software and decouple it from the hardware dependency. That's where we start to deploy these virtualized systems where we can then just initiate different instances of the process units that we need. Okay, so this NFV, this virtualized RAN is in the middle of cRAN and Open RAN. Okay, so cRAN, we centralized more things in the BBU, so you have in the pool of BBUs where we have a centralized processing system, but it's still proprietary and attached, hardware based basically, or proprietary based. With vRAN, we start to apply network function virtualization to decouple this hardware to software and start to allow for this disaggregation and start to allow that we can deploy different functions as we need.
Okay.
And then with ORAN, we go to the next level where we are basically opening the interfaces. Okay?
Okay.
Okay. So this is basically the process from LTE to centralized RAN.
It's like evolution.
To vRAN, yeah, to Open RAN. So in Open RAN, we can, because in cRAN, in vRAN, we are still depending on one vendor for the entire system mostly, even if we have some flexibility when to deploy each function with vRAN, but we still depend on the mainly on one vendor because all the interfaces between the different components are proprietary based. Okay, so
right.
I can't have a DU from one vendor and the CU from other vendor and the RRU from other vendor because
you have to have them
process
all talking to each other from the same vendor.
Exactly. So the interfaces are always proprietary dependent. With Open RAN, we are trying to take out this dependency in terms of communication, so we can have a DU from one vendor, a CU from another vendor, an RRU. So we are basically, the CPRI protocol is the initial idea of Open RAN is to make it open, which is the communication between the RRU and these two components, CU, DU. But then the next step is also to make this interface here open.
Okay.
With ORAN.
What do you think is going to be the biggest bottleneck for ORAN implementation and future development?
Yeah, so there are several challenges to Open RAN from my point of view. One of them, security, for sure. We already touched on it.
We already touched that.
Yeah. But then this is a completely new system, so I think it will depend on how the operators trust these new players, okay, and to deploy their systems. And it also depends, so for example, currently the existing vendors, okay, there's not much flexibility in the way they operate, but they provide good hardware, okay, so every function operates well for the needs that we have. Okay, Open RAN, I think it will depend on what exactly is the value that it can bring in practice. Okay, in terms of concept, it might bring a lot of value because it is flexible, it is open, we can have more players, more competition, so we can keep evolving into different ways. For example, if I deploy a network in a specific, let's say, for example, rural areas, okay, rural areas, we don't need this whole system that the main vendors provide because it's a too complex system for so low traffic demand usually. So in those scenarios, you can just request to a different vendor that has a simpler solution, and you can just proceed with that. For example, this is just an example where ORAN could be interesting in rural areas because we don't need the entire typical system. We might need just the simple functions, and we just can do it from a different vendor or a simpler solution. But on the other hand, it will depend how the market will evolve, because if we reach to a point where basically we still need all the entire processing capacity that was working before, or if, for example, this open system is not as the performance is not as good, if it raises a lot of issues, because it's a bit because we have seen mainly in other systems, in computer systems, and again I can give again the example of the console gaming, but it's the same for smartphones. We have seen that, for example, Android okay, is a much more open source, is a much more open system than iOS. Okay?
Yes.
But then we have what iOS with less hardware performs as good as Android with much better hardware. Okay, and we can have the same issue in this kind of systems. Okay, because the idea is similar. We are basically open the network doing an open source scheme, like for example Android operates, but it raises many more security issues, optimization issues, this kind of stuff. So it will actually, so the idea is very interesting, is very fascinating, but the way it will, if it will be the future or not, it's difficult to say yet, because it depends how it will work in practice.
Yeah. Does it help to reduce the costs of implementation potentially, because you're obviously increasing the competition in the market?
Yeah. I think one of the biggest, one of the very good aspects of Open RAN is exactly the costs. Not only because you will have more competition, you have more new solutions will appear all the time now, because almost any party can work as an as a vendor, because they can deploy functions. Even if they don't deploy the entire system, they can just deploy functions for DU, for CU. They can deploy very specific systems or functions for a very specific end product, and then the operators can just merge different functions from different vendors. But then how everything will operate together in terms of security, so in terms of optimization, how will that all merge together is still a bit unknown, and we can reach up to a point where most operators just go for the safest process, which is what we have.
Of course, like existing stuff is always the safest. So you kind of, it feels like you need one of the big players to just pick it up and just do it.
Yes.
And
because it will depend a bit on the use cases, but as I said, for example,
have its killer application. So it doesn't have a killer application yet.
Yes. But it's very promising. At least in general, I think the research community and even the industry is very confident on Open RAN, because of this all flexibility that we can do. But in practice, there are already some Open RAN based networks being implemented, but I don't know much about how are they operating at the moment. Hope to know it more in the future. Just add that Open RAN it also enables this flexibility, as I said, in terms of deploying the network system or the radio access network, but it also allows you to bring new services. Okay, so Open RAN will. The idea is that you can easily deploy machine learning mechanisms, for example. Okay, it's one of the big selling points that they are trying to make, is that because this will also have a centralized unit, which we call RIC, Radio Access Net Intelligent Controller. And it will be, so you will have this controller where we have basically a centralized unit with virtualization that manages the entire network, and we can deploy machine learning based functions on it and more easily interact with the base stations.
What will machine learning do for this? Give me an example.
So machine learning is important, is a very important topic in mobile systems. So what I'm saying about Open RAN is just it might help to deploy machine learning in mobile telecommunications. But you can do a lot with machine learning in mobile systems.